All right, so we are given that the distance between two coordinates is 5 root 13 in this example, and one of the endpoints is negative 8 comma 2, and the other endpoint, we know the x coordinate is 9, but we do not know the y coordinate. So we're going to go through this problem so that you can get an idea of how to try this problem out. So what we're going to use is the distance formula. So just to remind you what that is and what we're going to be plugging into, here is that distance formula laid out for us. So what I'm going to do is plug everything in. I know that my distance is 5 root 13. I know that my y coordinates are going to be, let's go with 2 minus y quantity squared. And then my x, since I use 2 first, I'll have to use negative 8 first. So it'll be negative 8 minus 9 quantity squared. All right, so to begin the solving process for this, we have to first get rid of this big square root here. And so to do that, I'm going to square both sides of the equation. This is going to allow me to take apart the distance formula. So on this left-hand side, we have to be really, really careful here when we're squaring 5 root 13. Whether you're using a calculator or not, we are squaring both the 5 and the square root of 13. And when you put that together, that is going to give us 325. And then over here, we now have released that big square root. It's gone. And I'll go ahead and actually just do this real quick. So that's going to be, what's that, 17? So 17 squared is going to be 289. All right, cool. Step 1 down. Now, the next part of this problem is we're trying to isolate this so that we can take away the square here by using square roots. So to do that, we just have to move the 289 over to the other side. And now we've isolated it. So 325 minus 289 is going to give me 36. So our whole goal, again, is trying to solve for this y. Since we now want to get rid of that square, because we can remove that parenthesis, we can then solve for y. We're going to take the square root of both sides. Now, unlike Pythagorean theorem, when we take the square root of both sides, we are allowed to have a negative y coordinate. So we are going to consider the fact that there are going to be two answers here. So this is plus or minus 6 equals 2 minus y. And so then essentially as our final kind of steps here, we're going to subtract 2 from both sides. Let's move over here since we're running out of space. So the y, actually it's negative y, so we need to be very careful with that. 6 minus 2 is 4. Negative 6 minus 2 is negative 8. And so currently those are both equal to negative y. What we need to do now is essentially multiply everything by negative 1. And so this is going to give me negative 4, positive 8, and y. So negative 4 and positive 8 are the two possible coordinates that will work for this. Now, as the last part of this, I'll give you a visual to show you why there are going to be two answers for this problem. All right, so this is just providing an extra visual on top of what we've already done algebraically to show you what the answer is. So we know that this point right here, negative 8,2, was definitely going to work. We know that this length needs to be 18.03. And so this black vertical line here that I have grayed out represents the value x equals 9, which we knew for a fact that the other point had to be on. So these are the only two places where we get the length of 18.03, which for the record is what 5 root 13 is. Now, if we actually wanted to extend this, for example, and not have the restriction of x equals 9, another thing we could look at here is this circle. If I actually zoom out here on this circle, that green circle represents everywhere that is 18.03 units away from this center value. Since we had restricted it to x equals 9, that's the reason why there are only going to be two places here, because there are two places on this circle that are both, I guess, horizontally 9 units away from this first point, but also their distance is going to be that 5 root 13 value. So use this video, including the visuals here, to help you identify how you can solve these other problems on your own.